You've probably heard about this one or seen it already, but this is the Peopoly Magneto X 3D printer. Peopoly sent it over free of charge. Their only ask was, would you be interested in giving Magneto X some test runs and see how it prints? So I said yes, and I did, and we'll find out if the Magneto is Magneto right after this. I'm Brian, and you are watching VV3D. Hello 3D printing friends and welcome back. Okay, so today we're getting a look at the Peopoly Magneto X. We'll go over the specs and features, see some prints, and I'll talk about my experiences with it, both good and bad. So let's get started. Here are the Magneto X's specs and features. The printer is built from aluminum extrusions and sheet metal, and it's definitely got a heavy-duty industrial vibe going on. The build volume on this thing is kinda unique at 300 millimeters on the x-axis, 400 on the y-axis, and 300 on the z-axis. I'm used to the x-axis being the left and right part, and the y-axis being the back and forth part, but this printer's motion system is arranged so that the x is back and forth and y is left and right. If it seems confusing, just remember, this is the x-axis, and this is the wide axis. See what I did there? Peopoly calls the motion system on this printer Mag-XY, but it has nothing in common with Core XY. To me, it's a regular Cartesian motion system with separate motors for the X and Y axes. What makes it interesting is that the X and Y motors are magnetic linear motors, so each motor spans the entire length of its axis. And each motor directly moves its axis, so there are no belts or pulleys like you'd have on a traditional Cartesian or Core XY motion system. Peopoly claims 3-micron precision with these motors, a printing speed of up to 800 millimeters per second, a maximum travel speed of 1500 millimeters per second, and acceleration up to 22,000 millimeters per second squared. Peopoly also says these motors have closed-loop control, meaning there shouldn't be layer shifts due to skip steps. In other words, the motors are supposed to know where they are relative to the build volume. The tool head on the printer features a direct drive extruder that they call the Lancer, with a reverse Bowden setup to guide filament into it. There are dual parts cooling blowers on either side of the tool head to quickly cool your print before the next layer goes down. There's a filament runout sensor so it can let you know when you need to run out and get more. To get filament into or out of the tool head, there are handy load and unload buttons on top. Every press of the load button feeds in another 20 millimeters of filament, as long as the nozzle is hot enough. Speaking of that, the printer comes with Peopoly's standard Lancer hot end with a 0.4 millimeter hardened steel nozzle that can get up to 300 degrees Celsius. You can also purchase the short or the long Lancer hot ends. The main difference between them seems to be the maximum flow rate and the nozzle that comes with them. The bed is an 8 millimeter thick slab of aluminum that can get to a maximum of 130 degrees Celsius. The build plate on the bed is a magnetic spring steel sheet with a textured PEI coating on both sides. With the big 300 by 400 millimeter print area, that makes it easy to remove finished prints from the printer. The bed is raised and lowered by 4 independent Z-axis stepper motors and lead screws. Having 4 independent motors lets the printer perform quad gantry leveling, making sure each corner of the bed is at the same level relative to the nozzle. Leveling is accomplished with the help of a load cell sensor in the tool head. The printer uses the nozzle as a bed probe, creating the 48-point mesh to map out the high or low spots on the bed. The Magneto X runs Clipper firmware, controlled by a large 7-inch color touchscreen with the Clipper screen user interface. Under the hood, there's a 48-volt DC power supply for the linear motors and a 24-volt power supply for the rest of the electronics. The motion control system is handled by a Big Tree Tech Octopus Pro board, and Clipper lives on an Orange Pi 02. It has Ethernet and Wi-Fi on board, and if you don't want to put the printer on your network, it has a USB port so you can print files from a flash drive. There's also a 1080p camera on board, allowing you to monitor the progress of a print job remotely or make time-lapse videos of your prints. And although the unit Peopoly sent didn't include an enclosure, the website shows that the printer now includes it. The printer also comes with a small set of useful tools: hex keys, screwdriver, a rod to help clear filament jams that may occur, and flush cutters. Note that I skipped making the joke about the clipper-based printer including clippers. You're welcome. And with that, we'll move on to the next part of the video. So I printed a bunch of things in this Protopasta HT-PLA erratic indigo filament, which has some really cool color transitions. And if any of these models interest you, I have all of them linked in the description. The first thing I want to show you is this Kleenex cube. This is a model I designed a few months ago for Halloween, and back then I printed it in candy corn colors. I thought it looked pretty cool, but in the erratic indigo, it looks even cooler. Quality-wise, the y-axis has this kind of odd pattern on the surface, but the x-axis doesn't have that. Anyway, it perfectly fits a standard Kleenex cube, and the color is cool, so this will see some use, what with cold season being upon us and all. Next, it's Aria the Dragon by Luby 3D. The color transition on this filament from dark to light was nice. She printed pretty well, with her only big issue being some ringing artifacts that you can see along the sides of her wings. Hardly any stringing to speak of, and overhang performance was good. Now here's the gear bearing by Emmett Lalish. This one is a print-in-place model, meaning it's got moving mechanical features, in this case herringbone gears, but it prints as a single model. The ringing artifacts show on this one as well, though they're more like gentle ripples on the surface of the wheel. The only other big issue on this print is the Z seam, and I think with some additional calibration, that could probably be minimized. When it first came off the bed, some of the gears were very slightly fused to their neighbors, but with a few minutes of pushing and pulling on them, I was able to break them free. And now it spins like it's supposed to, so I'm calling this a success. This is the Hubless Motorcycle, a little printable toy by designer Rich Mitch. It too is a print-in-place design with spinning wheels. It turned out pretty good. I see a Z-seam hidden in the back wheel ring, but other than that, it doesn't really seem to have any huge issues. Plus, the wheels roll fine, so I'm happy with it. Here's the articulated axolotl that I print-a-lotl. It's from designer AK Inferno. This one had no issues printing. The surface finish on this one seems fine. I don't see ringing or anything on it. The little segments move like they should, and it's rich in wiggly goodness. This is one of my favorites to print, and my kid likes them too. She gives them out to her friends at school. Up next, MacGyver's Caladragon. The surface finish on this one turned out good, nice and glossy and smooth. The backs of the antlers turned out great, which indicates good parts cooling performance. The chin overhang is also good. And I don't see any stringing. So what happens if I scale it up to 750% size? We get this. Printed in Protopasta bottle green, it looks really nice. When it's this big, it needs supports, so I used tree supports on it. I ran into a snag where one of the supports got knocked off the build plate, but the printer was actually able to recover. Air printing the supports under the chin eventually worked out for it, and I was kind of impressed by that. Surface finish-wise, there are some glossy versus matte issues caused by the printing speed, and if I was going to reprint this, I would set the outer wall speed to go slow for a consistent gloss. But apart from that, I think it came out great and I like it. Also, it's enormous. Okay, now we're switching filament from Protopasta HT-PLA to the spool of PETG-CF that Peopoly included with the printer. So here's a 100% size Caladragon in carbon fiber reinforced PETG. This has a beautiful surface texture to it and no stringing. It's about as flawless a print as I could expect. I also printed Aria the Dragon in this filament, and while the filament itself looks great, the print still has those ringing artifacts on the wings. Moving on to a blocky, non-organically shaped model, here's a Calicat by Design. This shows pretty severe ringing on the left and right sides of it, and none on the front and back of it. And that ringing is all on the y-axis. And this is after running the input shaper calibration multiple times on the printer. Anyway, we'll talk more about those artifacts a little later, but the front of it looks super good. Here's the last print. Now, I know I've shown like 10 prints before it. I feel like I'm oversharing, and that's one of my mini vices. Yes, it's the Mini Vice by designer MS. This came out pretty good, and it was easy to assemble. The screws and threads work like they're supposed to. I can attach it to the edge of my workbench and use it to clamp things. Overall, it's a pretty good practical print, and with that, print show and tell is done, and we'll move on. So now I'll talk about my experiences using the Magneto X. I have the current version of Orca Slicer on my computer, and the Magneto X is a printer it knows about. So adding it was just a matter of checking a box in the Add Printer thing. I also put the printer on a Wi-Fi network using the printer's touchscreen. So I was able to connect Orca Slicer to the printer over the network, which is super convenient for sending print jobs. I went through the initial calibration stuff like input shaping, quad gantry leveling, and getting a mesh of the bed. I will say that the first layers on my prints have been good. With the exception of one piece of supports on that big green Caladragon, the prints always stick and stay stuck until I flex the plate to remove them. That said, I did run into a few issues. One of the things I noticed is that the linear motors make a weird noise when they're energized. They're quiet when they're off, but they sound odd when they're on. While printing, some of the fans are loud, but when the printer's idle and the linear motors aren't powered on, it's not terrible at all. Early on, one of the 2 parts cooling fans fell off the toolhead. Whatever adhesive Peopoly used to glue the magnets into the toolhead just didn't hold. So when the adhesive let go, the magnets stayed stuck to the metal strips on the fan module and the whole little module fell off. I checked the other fan, and 2 of the 4 magnets on that one had come loose from the toolhead as well. So I ended up re-gluing the magnets into the toolhead with E6000 adhesive, and they've stayed put since. Another problem I have with the printer is this wild filament path. The printer uses a PTFE tube in a reverse Bowden configuration, so it's acting as a guide to get the filament from the spool into the extruder. But that tube has to make several turns and also runs through the cable chain on the way to the tool head. I get that it's supposed to keep the tube out of the way, but that seems kind of excessive. I noticed that it was really hard to push the filament through the further it got into the tube. I disconnected the tube from the tool head and found that once the filament was peeking through, it was just as hard to pull as it was to push. The amount of friction through that filament path is enormous, and it's right at the edge of how much force the extruder can apply to pull it through. Like with a light pinch on the filament at the input side, the extruder couldn't pull it through the tube. The motor just clicked as it tried. So I changed the path. I designed a simple part to raise the input side of the tube up a bit, and I have the PTFE tubing pointing up instead of sideways. That keeps the tubing out of the way of the Mag-XY motion system and significantly reduces drag on the filament. I had another problem, and this is a weird one. I started a print that was going to take about an hour and went to bed. The next morning the print was done, but the printer was quiet. A little too quiet. The power switch was on, and the light inside the power switch was on, so the printer should be on, right? Wrong. It was dead. Or so I thought. I didn't know it at the time, but the Magneto X has a circuit breaker underneath it. Did you know that? I did not know that, but now I do. So anyway, I reset the circuit breaker, and then I could power up the printer again. But that left me with a question, and I don't know the answer to it. The print job had finished, so the nozzle and bed heaters were no longer powered, and the printer had enough time to render the time-lapse video of the print, so what in the world would cause an idle printer's circuit breaker to trip? And like I said, I don't know why that happened, I only know that it happened. So if you have any thoughts on that one, I'd love to see them down in the comments. And one last thing, and this is kind of a big one, is the print quality. The main issue I see is ringing, or maybe it's VFA, or vertical fine artifacts. Despite the name, they are not, in fact, fine. The issues are more apparent on the y-axis, and maybe that's because the y motor is moving the mass of both the x and y axes. I spent hours printing calibration print after calibration print after calibration print and adjusting settings, trying to get it dialed in, or at least under control. I printed temperature towers, I printed flow ratio calibration, I printed pressure advance calibrations, I printed retraction calibrations, I printed VFA calibrations, I performed the input shaping calibration multiple times, and I printed a bunch of boron cubes and orca cubes to test the results of all this. I even chatted with Peopoly's technical lead for the Magneto X, trying to get these issues resolved. In the end, the suggestion was to force the printer to always keep its print speed above 150 millimeters per second. And in conjunction with all the other calibrations, it did improve the quality. Here's an example. This is the before print, a Voron cube printed with a Magneto's 0.16mm optimal settings in Orca Slicer. It's got serious ringing or ripples in the outer skin of the print, particularly on the Y faces. And here's the after print using the 0.16mm optimal settings, after flow ratio calibration and pressure advanced calibration and VFA calibration, and setting the minimum print speed to always stay above 150 millimeters per second. The printing artifacts are significantly reduced, but here's the same model printed on a Bambu Lab X1 carbon with the same filament sliced in Bambu Studio using the 0.16mm optimal settings with exactly 0 calibration and 0 settings modifications. To my eye, it's a better print. Now, I don't usually compare one printer to another like this, but I wanted to see how the filament performed in another printer. And I'm not saying the Magneto X is horrible. The linear motor design is something we haven't seen on a 3D printer before, and I think it's cool that Peopoly believed in it enough to push ahead with it. To be clear, the Magneto does have a lot going for it. The build quality on the printer is top-notch. It's got a big build volume, a super sturdy frame, beautiful machined aluminum parts, a thicker than average aluminum heated bed, an actually good camera that makes for good time-lapse videos. It's just a beast of a printer and beautiful in an industrial sort of way. But as nice as the Magneto X is, in my experience, it isn't a machine that consistently prints great right out of the box. I think that while the results are good on some models, other models will require you to tweak the settings. So be prepared to do a fair bit of tuning and calibrating and dialing in if you get one. So that's the Peopoly Magneto X 3D printer. Thanks to Peopoly for sending it over, and big thanks to everyone who supports the channel, whether with channel memberships or by using the links in the description. If you liked this episode, give it a thumbs up and maybe subscribe so you don't miss new ones. Well, 3D printing friends, that's about all the time we have for this one, and now that we're at the end, let's go print something cool.